Good morning, students. So let us start our new topic with this method. Let us discuss some of the properties of inverse trigonometric functions. We all know sine inverse x is equal to y gives us sine y is equal to x. So let us put y is equal to sine inverse x here. It gives you sine of sine inverse x is equal to x. That is inverse of a function gives us identity where x belongs to its minus 1 to 1, or we can write sine inverse of sine x. Here inverse function is outside, is equal to x when x belongs to close interval minus pi by 2 to plus pi by 2, because we know that this table, it gives us inverse trigonometric function domain and range. Now whatever the domain was of Now let us discuss some of the properties of inverse trigonometric functions. Let us take first property. Sine inverse 1 upon x is equal to cosec inverse x, where x is more than is equal to 1. Similarly, cos inverse 1 upon x is equal to sec inverse x. And so we can write tan inverse 1 upon x is equal to cot inverse x, and vice versa. Cosec inverse x also gives us sine inverse 1 upon x. Now let us prove tan inverse 1 upon x is equal to cot inverse x. So let us take cot inverse x is equal to y. It gives us x is equal to cot y, and 1 upon x is equal to 1 upon cot y is equal to tan y. So it gives you tan inverse 1 upon x is equal to y. So finally we got tan inverse 1 upon x is equal to cot inverse x. And similarly we can prove all these three properties like sine inverse 1 upon x, and see just the difference between sine and tan. Similarly, cos inverse 1 upon x is equal to sec inverse x. So it's very easy for us to prove it. Let us discuss second property. Sine inverse minus x is equal to sine inverse x minus का sine inverse x. So x belongs to its minus 1 to 1, and tan inverse minus x is equal to minus tan inverse x. X belongs to real numbers, and cosec inverse minus x is equal to minus cosec inverse x. So to prove this property, let us start with tan inverse minus x. Let us consider tan inverse minus x is equal to y. It gives you tan y is equal to minus x, and x is equal to minus tan y when take minus sign opposite side. And we all know tan is negative in fourth quadrant, so we can write it as tan minus y. So it gives you tan inverse x is equal to tan inverse of tan of minus y. It implies tan inverse x is equal to minus y. We all know tan inverse of tan theta is equal to theta using that property. So after substituting, tan inverse x is equal to minus tan inverse minus x. Let us take minus opposite sign, and it gives you tan inverse minus x is equal to minus tan inverse x. Similarly, we can prove other properties related to the same. Sin inverse minus x is equal to minus sin inverse x, and for cosec inverse minus x is equal to minus cosec inverse x. Make sure that all these three functions are negative in fourth quadrant and their domain is minus pi by 2 to plus pi by 2. Let us take third property. Cos inverse minus x is equal to pi minus cos inverse x. Similarly, sec inverse minus x is equal to pi minus sec inverse x. Similarly, cot inverse minus x is equal to pi minus cot inverse x. All these three inverse functions having their range in first and second quadrant. So let us prove first part. cos inverse minus x is equal to pi minus cos inverse x. So let us start. Let cos inverse x minus x is equal to y. It gives you cos y is equal to minus x or x is equal to minus cos y. Now we can write this minus cos y as cos pi minus y, because we all know cos pi minus theta is equal to minus cos theta. So it gives you x is equal to cos pi minus y. Now let us take cos on opposite side. It gives you cos inverse x is equal to pi minus y. Substituting the value of y, it gives you cos inverse x is equal to pi minus cos inverse minus x. It gives you cos inverse minus x is equal to pi minus cos inverse x. Let us prove third property. Other two property of third property we can prove easily. Sec inverse minus x is equal to pi minus sec inverse x. Similarly, cot inverse minus x is equal to pi minus cot inverse x. Same thing, you have to follow the same steps to prove the same property. Let us discuss fourth property, which is sin inverse x plus cos inverse x is equal to pi by 2. We all know cos and sin are complementary angle. Similarly, tan inverse x plus cot inverse x is equal to pi by 2. And third one is cosec inverse x plus sec inverse x is equal to pi by 2. All these three are pair of complementary angles. So let us start with one property, tan inverse x plus cot inverse x is equal to pi by 2. So let us take tan inverse x is equal to y. It gives you x is equal to tan y and x is equal to cot pi by 2 minus y. As we all know, tan theta is equal to cot 90 minus theta. So let us replace tan y by cot pi by 2 minus y. Now let us take cot on opposite side. It gives you cot inverse x is equal to pi by 2 minus y. Let us replace y is equal to tan inverse x. And then it gives you cot inverse x plus y is equal to pi by 2 and put y is equal to tan inverse x. So it gives you cot inverse x plus tan inverse x is equal to pi by 2. Let us discuss other two properties also in the same way and quite easy for us to prove, just like sin inverse x plus cos inverse x is equal to pi by 2, same follow method, and cosec inverse x plus sec inverse x is also pi by 2, same method. Property 4 gives you same. Let us discuss fifth property, sum of angles for tan. Tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy when xy is less than 1, and tan inverse x minus tan inverse y is equal to tan inverse x minus y upon 1 plus xy when x plus y is greater than minus 1. So let us start with this property. Try to recall formula for tan a plus b, and to use that let us take tan inverse x is equal to a and tan inverse y is equal to b. It implies tan a is equal to x and tan b is equal to y. It gives you tan a plus b is equal to tan a plus tan b upon 1 minus tan a tan b. Let us take tan a is equal to x, tan b y, and it gives you tan a plus b is equal to x plus y upon 1 minus xy. Take tan on opposite side, or you can apply tan inverse both sides. Same thing. Let us apply tan inverse both sides, and it gives you tan inverse of x plus y upon 1 minus xy is equal to a plus b. And now recall what is a and what is b. A is tan inverse x and b is tan inverse y. So we get tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. So other property can be used same way, and same formula we have to apply tan a minus b now. tan A minus B is equal to tan A minus tan B upon 1 plus tan A tan B. Here we have taken alpha and beta. Now let us think about sixth property of inverse trigonometric function. 2 tan inverse x is equal to sin inverse 2x upon 1 plus x square, and cos inverse 1 minus x square upon 1 plus x square, and in the form of tan itself, 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square. Just recall all the formulas: sin 2 theta, cos 2 theta, tan 2 theta in terms of tan. We have to just inverse them. Let us start with this. Let us take tan inverse x is equal to y. It gives you x is equal to tan y, and take right hand side only. Sin inverse 2x upon 1 plus x square. Here x is equal to tan y we have to replace. It gives you sin inverse 2 tan y upon 1 plus tan square y. And we all know it is the formula for sin 2 theta. If you remember, sin inverse sin 2y, because 2 tan theta upon 1 plus tan square theta is sin 2 theta. Now here sin inverse of sin 2y, that is inverse of a function, is applied on a function, gives you identity, that is 2y, and y is equal to tan inverse x, so it gives you 2 tan inverse x is equal to left hand side. That is what we have to prove. So result is 2 tan inverse x is equal to sin inverse 2x upon 1 plus x square. Similarly, you can prove the properties related to 2 tan inverse x. Here we have to recall formula for cos 2 theta is equal to 1 minus tan square theta upon 1 plus tan square theta. And for 2 tan inverse x also, try to recall formula for tan 2 theta, that is 2 tan theta upon 1 minus tan square theta. So we have just discussed property 1 related to reciprocal of the values. Sin inverse x, sin inverse 1 upon x is equal to cosec inverse x. Similarly, cosec inverse 1 upon x you can prove as sin inverse x. Here cos inverse 1 upon x is equal to sec inverse x. Similarly, you can prove sec inverse 1 upon x is equal to cos inverse x. And tan inverse 1 upon x is equal to cot inverse x. Its reverse is also there. Cot inverse 1 upon x is equal to tan inverse x. This was property number 1. Now let us think about property 2. Sin inverse minus x is equal to minus sin inverse x, where x belongs to minus 1 to 1. Tan inverse minus x is equal to minus tan inverse x, and cosec inverse minus x is equal to minus cosec inverse x. Now property number 3, our recap is related to property 3. Cos inverse minus x, pi minus cos inverse x. Sec inverse minus x is equal to pi minus sec inverse x for all x greater than is equal to 0, and cot inverse minus x is equal to pi minus cot inverse x for all real values of x. Now property number 4, sin inverse x plus cos inverse x is equal to pi by 2, where x belongs to minus 1 to 1. Tan inverse x plus cot inverse x is equal to pi by 2. Similarly, cosec inverse x plus sec inverse x is equal to pi by 2. All these three are pair of complementary angles. So you have to learn it by complementary angles property. Property number 4. Now let us think about property number 5. Sum of angle for tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy, where xy is less than 1. Now next is tan inverse x minus tan inverse y is equal to tan inverse x minus y upon 1 plus xy, For these two property, you have to recall your formula for tan a plus b and tan a minus b. Now twice angle formula. 2 tan inverse x, 6 property is 2 tan inverse x is equal to sine inverse 2x upon 1 plus x square. Here we have to use sine 2 theta is equal to 2 tan theta upon 1 plus tan square theta. Similarly, 2 tan inverse x in terms of cos gives you cos inverse 1 minus x square upon 1 plus x square, where you have to recall cos 2 theta is equal to 1 minus tan square theta upon 1 plus tan square theta. Similarly, 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square. So thank you students. Please try your questions.